Good day. Today we are on lesson number 9. In the previous lesson, there was an activity, which was activity 8. Here are the answers. The chapter is still differential calculus, and today's topic, maxima and minima. This is the application. Maxima and minima are the respective plural of maximum and minimum. To find maxima or minima, we use f prime of x equals to 0. Okay, in the previous lessons, we have determined the stationary points, which were the local maximum and the local minimum. At those points, the gradient was equals to 0. That's why here we have f prime of x equals to 0. Example. A drinking glass in the shape of a cylinder must hold 200 milliliter of liquid when full. Here's the glass. Number A. Show that the height of the glass h can be expressed as h equals to 200 over pi r squared. Number B. Show that the total surface area of the glass can be expressed as S of r equals to pi r squared plus 400 over r. Number C. Hence, determine the value of r for which the total surface area of the glass is a minimum. Solutions. The volume. Remember to calculate the volume. We find that the volume equals to area of the base multiplied by the height. So the base of our glass is a circle. So area of a circle is pi r squared. And the volume is given there. It's 200 milliliters. Therefore, we have 200 equals to pi r squared multiplied by h. Then we solve for h. Solving for h, we have h equals to 200 over pi r squared. Number B. This is our glass. Our glass, it is opened at the top. So it means we are not going to include this part in our calculation. The base is the circle. Here is the circle. And we have the rectangle. This side, the yellow color, is the rectangle. Okay. We have the circle and the rectangle. And then here I've written 2 pi r. Where is this 2 pi r coming from? Okay. So this is the side of a rectangle, which form the part of the circumference. So the circumference of a circle, C equals to 2 pi r. That's why here I have written 2 pi r. Therefore, we have area of a circle equals to pi r squared, and area of the rectangle equals to 2 pi r multiplied by h. Now we determine the surface area. So you must remember that the surface area is the sum of the area of all the faces. So that's why here I'm adding the area of the circle plus area of the rectangle. Therefore, we have S of r equals to pi r squared plus 2 pi r h. But this h, we have calculated it above there. H equals to 200 over pi r squared. Therefore, we have SR equals to pi r squared plus 2 pi r into 200 over pi r squared. Then we simplify this. Simplifying this, we have S of r equals to pi r squared plus 400 over r. Number C. We have S of r equals to pi r squared plus 400 over r. And then we are asked to determine the value of r, which will give the glass, the volume of the glass, a minimum. So it means we are going to differentiate this, meaning that we have to let s prime of r equals to 0. We differentiate this, we equate this to 0, and we solve for r because r is going to be the only variable. But before we do that, let's simplify this. We have pi r squared plus 400r to exponent -1. Now we differentiate. S prime of r equals to 2 pi r minus 400 r to exponent -2. S prime of r equals to 2 pi r minus 400 over r squared. And then we equate this to 0. 2 pi r minus 400 over r squared equals to 0. Therefore, 2 pi r cubed minus 400 equals to 0. We get this after multiplying each and every term by r squared. Now solving for r, we have a cubic root of 400 over 2 pi. Therefore, r equals to 3.99. Activity 9. Consider a rectangular reservoir below. And then here are the questions. See you in the next lesson.